Okay, chapter 11, day 4. What we're going to focus on is how do we graph inverse trig functions and how do we write equations of trig functions. So we had two things today. First is graphing inverse, and then how do we write equations. So first of all, inverse. They're a reflection across the line y equals x, just like the inverse graphs we drew earlier in this year. So what do? We graph the original, switch the x and y coordinates, and regraph is how we graph it, make an inverse of a trig function. Okay? So, if the original is cos, the inverse is called arc cos, or an angles whose cos is. Okay? Arc cos, or sometimes you'll see it written this way, cos -1. It's almost like cos to the -1 of x. But we just read this as inverse cosine of x. Sin x, arc sin x. Tan x, arc tan x. Okay? That's how we use notation. On your calculator, you hit like second cos, second sine, second tan. So for example, let's graph arc cos. Well, what did we say? You have to graph the original, switch x and y, and regraph. So I graph the original. All right? Here's my original cos graph. Just a standard y equals cos. So, starts at 1, 0 at pi over 2, -1 at pi, 0 at 3 pi over 2, back to 1 at 2 pi. I make a table of values. Trade the x and y. So this cos graph, the arc cos, is really a cos graph then that starts at 1, 0. So here's 1, 0. And then it will go up the y-axis instead of across the x-axis. And so, looking from the side, I can definitely see it's a cosine graph, but you notice it starts on the x-axis at 1, 0, and then it heads sideways up the y-axis. It is a reflection across the line y equals x. If I were to put that line in there, you'd see it's a mirror image across it. Okay? Let's try graphing arc sine. So if I graph arc sine, I don't know what happened to this little piece here. There we go. Okay. Arc sine. It's a sine graph that will start at the origin, or 0, 0. Okay? And then goes up the y-axis. Notice, if I draw the initial sine graph, we're at center line, max, center line, min, center line. So if I take these coordinates and flip them, it still starts at 0, 0, and then it works its way up the y-axis. Okay? So from here, goes here, here, here. And that is your arc sine graph. It again reflects across the line y equals x. They're just two graphs that on your test they're going to ask that you be able to recognize. And the biggest difference between the two is sine again starts at the origin, where arc sine starts at the origin, where arc cosine starts at on the x-axis at 1, 0. The biggest thing we're going to talk about today is how do we write equations of trig graphs. That's something that occurs on every test, and we got to be able to work backwards into writing equations. So there's a process you have to do to identify all the pieces of the trig graph. So the first thing, you got to decide if it's a sine or cos curve, and whether it's a positive sine, positive or negative sine, positive cos, negative cos. So remember, sine starts at center line, cosine starts at a max or a min. Second thing, we need to calculate the amplitude, which is half of the difference between the max and min. If my center line is 0, it's real easy to find. If my center line is not 0, then it's a little bit harder to find. I need to do the formula. Identify the period, and that's the time it takes to do one cycle. What's usually easiest is find two peaks, okay? Find two peaks and find the distance between the peaks, or two valleys. It's probably the easiest way to find the period. Calculate the frequency. So when we graphed them, we knew the frequency and we calculated the period. to get the equations, we have to find the period and calculate the frequency. And the frequency is either going to be 360 or 2 pi over the value we got for the period. We have to calculate the center line. Now, if the center line is at 0, that's real easy to see. Otherwise, you take your max plus your min and take half of that, and that will be your center line. You're taking your average, will be the center. Phase shifts we really won't do until pre-calculus, so you won't have to worry about phase shifts. But if this was pre-calc, you would. And then you're going to write the equation, and the equation has the same format we've been working in. The amplitude, and then it's either sine or cos, the frequency, the x. Now, if there is a phase shift, it would be located inside parentheses. For our business, you can pretty much forget about phase shift. Okay? Center line gets tacked on at the end. So watch. Let's write the equation for the following. All right? So here's the graph. Okay? Here's the graph. We notice it is a positive cosine graph because it starts at a max. Positive cos graph. Amplitude is 1/2 max minus min. The max is 4, the min is -4. Amplitude would be 1/2 4 minus -4. The period, peak to peak, took me 12, so the period is 12. Frequency then, I'm not working in degrees. If I was, you'd see degree symbols. 2 pi over 12, which reduces to pi over 6. Center line, max plus min, so 4 plus -4, half of that is still 0. So then we write the equation. Y equals the amplitude cos the frequency. Amplitude cos frequency x. Don't forget the y and the x in there. But that's how you write equations. There was no phase shift in this, and again, we're not going to worry about phase shift until we get to pre-calc. But that's how you write the equation. You have to identify, is it sine or cos? Is it positive or negative? What's the amplitude? What's the period? Calculate the frequency, calculate the center line, and then you write it. And that's it.